Welcome to Stage 4, the part of the course where we stop talking about hardware and start talking about the software that actually brings it to life. You use an operating system every second of every day, but most people never really see it. Over the next 8 pieces, we'll fix that. 5 core jobs the OS handles, the kernel userland boundary that keeps everything secure, how processes really work, and a quick tour of Windows, macOS, and Linux. By the end, you'll read a process list fluently and finally know why a crashing browser doesn't take your whole machine down. So let's make that invisible layer visible. The OS juggles 5 core jobs, all running at once. First, process management. The scheduler hands out CPU time in tiny slices, hundreds of times per second, so Chrome, Spotify, and your system services feel simultaneous. Second, memory management. Every app thinks it owns all your RAM, but the OS quietly hands out virtual address spaces and isolates them, which is exactly why one crashing app can't poison another. Third, the file system turns billions of raw disk blocks into files, folders, and permissions, NTFS, APFS, ext4. And fourth, I/O, drivers, and security. Every mouse click, keystroke, and network packet is mediated by the kernel. Keep that word kernel in mind. Subwords, it's where we're heading next. And here's the kernel. Think of your operating system as having 2 layers, a small, all-powerful core called the kernel that talks directly to hardware and userland. The big sandbox playground where Chrome, Word, and Spotify live. The kernel runs at what's called ring 0, with root access to everything. If it crashes, you get a blue screen or a kernel panic, and the machine is done. Userland apps can't touch hardware directly. They have to ask through system calls. That's the bridge we'll look at next, and it's exactly why your browser dying doesn't take your whole PC with it. Privilege escalation bugs that break this boundary sell for $50,000 to $2 million, because this line right here is computer security. So let's stack the whole thing top to bottom. You, the human, sit at the top. Below you is userland, your apps, shells, the GUI. Those apps call into system libraries like libc or the Win32 API, which translate requests into syscalls down to the kernel. The kernel schedules the work and hands it off to drivers, and only the drivers actually touch the hardware, CPU, RAM, disk, network. Each layer only talks to its immediate neighbors. Memorize this picture, because every troubleshooting question you'll ever face lives somewhere on this ladder. Now zoom into userland and look at what's actually living there. Processes. A process is just a running program. Chrome.exe sitting on disk is a file, but the moment you double-click it, the OS loads it into memory, and that live instance becomes a process with its own identity. Every process gets a PID, owns its own memory and open files, and runs work through threads, which is why one browser can light up all your CPU cores. And when something hangs, you now know the move. Find the PID, kill the process, and the OS cleans up the mess. PID 1, though, you leave alone. That's in it, the parent of everything. So if every OS does the same 5 jobs you just learned, why does sitting at a Mac feel nothing like sitting at a Windows box? It comes down to taste and target user. Windows owns the desktop with 70% share, built for hardware variety, gaming, and enterprise tools like Active Directory. macOS plays the premium creative angle on Apple's own hardware, polished but locked in. And Linux, barely a blip on desktop, but running 95% of web servers and every top supercomputer. Same kernel userland pattern underneath. Windows favors familiarity. macOS favors aesthetics. Linux favors transparency, where everything is a file. Pick by job, not religion. Enough theory. Let's put it to work. 4 real help desk tickets, and your job is to spot which OS layer is breaking. Ticket 1, Chrome frozen. That's a userland process stuck, so task manager, end task, done, no reboot. Ticket 2, idle machine crawling. Open the process list, sort by CPU, and you'll usually find antivirus, Windows Update, or telemetry eating the box. Ticket 3, blue screen every morning. That's kernel level. meaning bad RAM, a corrupt driver, or a failing disk. Grab the stop code and chase it down. Ticket 4. Printer driver crashed everything. Drivers run in kernel space, so boot into safe mode, uninstall, and reinstall only assigned vendor driver. Notice the pattern. Process problems you kill. Kernel problems you investigate. Before we close out, lock in the language. These 12 terms are the vocabulary you'll hear on every ticket, every config, every OS class going forward. Kernel and userland as the two halves, syscall as the bridge between them, process and PID and thread for what's running, driver for the kernel's hardware translator, BSOD and kernel panic for when it all falls over, and distro plus system for the Linux side. Memorize this column. It's the junior OS tech dialect, and the rest of stage 4 assumes you speak it. Now, with that vocabulary in hand, let's clear out the myths that trip up junior techs on real tickets. More RAM doesn't always mean faster. Past a sane ceiling, the bottleneck moves to disk or CPU, and an SSD swap usually beats a memory upgrade. Macs do get malware, just less of it. Closing apps on modern OSes often just parks them in cache, so chasing free RAM is wasted effort. Linux on the desktop is genuinely friendly now. And the big one, tying back to what we just covered, drivers live in kernel space. A sketchy driver is full system compromise, so install only from the vendor or the OS itself. So that's lesson 26 in the bag, and stage 4 is officially live. You now know the 5 jobs every OS does, why the kernel sits privileged above your apps, what a process actually is, and that Windows, Mac, and Linux are solving the same problem in different dialects. Next up, lesson 27. We get hands-on with Windows, NTFS, the dreaded registry, services, and the daily tools. You'll actually click on a help desk shift. 7 OS lessons left in this stage. See you there.